Good afternoon. So today we will be discussing section 1.5 of geometry, which is angle relationships. The words that you will see on this board today, you may recognize from previous grades or not, but we will be going over them anyway. So let's begin. Firstly, we have vertical angles. These are basically angles created by two lines that intersect at a certain point. So let's look at the example. We have lines over here. We have lines EF and GH. They intersect at the point I. One thing we must know about vertical angles is that they are always congruent to each other. So let's look at, let's say, angle GIF and EIH. These angles here and here, they are congruent to each other. And let's take another example like EIG and HIF. These two angles over here, they are also congruent. Next, we have adjacent angles. These are basically angles that are neighboring and they share a common side. So let's look at the example over here. We have angles ABC and CBD. Now, what makes these angles adjacent is that one, they are neighboring, but they have a common side. That is the core thing to making like two angles adjacent to each other. They share a common side. Angles ABC and CBD, they share the common side, which is BC or CB, however you want to call it. Now, let's talk about perpendicular lines. So those are basically two lines that intersect to form a right angle, or right angles, I should say. So let's look at the example that I put on the board right here. We have lines AB and CD. Now, to indicate that those lines are perpendicular, there is a block over there. There's a block over there, and that indicates a right angle. When two lines intersect like that and there's a block there, that indicates that those lines intersect at 90 degrees, which is a right angle. That indicates that lines are perpendicular to each other. And then another thing that can tell you that two lines are perpendicular to each other is this symbol over here. That when you see that symbol, maybe on a test or in a book, just know that that indicates when two lines are perpendicular to each other. Let's now talk about a linear pair. A linear pair is basically two lines that intersect. They are adjacent to each other and they add up to 180. So let's look at the example over here. We have two lines, which is AB and CD. They intersect with each other and they form two adjacent angles, as you can see here and here. Now those adjacent angles add up to 180. A linear pair, the angles always add up to 180. Linear pair, another word for 180, or another way you can refer to 180 is supplementary. Supplementary angles are 180, and so the angles of a linear pair add up to 180. Let's go over some examples now just to review the things we have learned today. So right here we are asked to find a linear pair. Now we went over what a linear pair is, and that is two intersecting lines creating two adjacent angles that add up to 180. So every time you hear linear pair, just think of 180. It will help you a great deal when answering a question like this. So as you can see here, we have angle ACD, and it equals 115 degrees, or 115 I should say. And we have angle DCB, and it equals 65. 65 plus 115 will give me 180, and these angles are adjacent. They share a common side, which is DC, So we'll put that down. So we have angle, we have angle ACD, and we have angle DCB. And there are certainly others you could put down, like you could say ACE and ACD are a linear pair because they also equal to 180, because angle angle ACE, it is 65 and ACD is 115, so that also equals to 180. So you don't have to stick to just one answer, but this was just my example. Another example here, it's asking us to find x so that line GJ and line EI are perpendicular. These two lines here, GJ and EI, perpendicular. Now the word that should come to you as soon as you hear perpendicular, you should think of the number 90. So we're solving for x, so these two intersect at 90, so they are perpendicular. So we can say, to solve for x, 6x plus 3x equals 90. Because again, I say we're solving for x, so these two lines intersect at 90. Let me scratch it out, it looks bad. We apply our algebraic skills here. 6x plus 3x equals 9x. We keep saying 90. Now we need to separate the x to leave it alone because the variable holds a value. So we divide it by 9 on this side. Whatever you do on this side, you do on that side. So we're also going to divide by 9 here. And then with x, 90 divided by 9 is 10. So now we can now substitute 10 into the places of the x. So we can say 6 times 10, it will give us 60. And 3 times 10, it will give us 30. 60 plus 30 equals 90. There we are.